Hey there. Today we are going to go over branching in conditionals in C++. This is just a fancy way of saying, for those familiar with the programming concept, if statements. In other words, making decisions about what code is actually going to be run based on a Boolean expression, something that is either true or false. So our first exercise here has nothing to do with that and actually is just a little bit of a puzzle, which is to write a program that swaps the values of two integer variables without using a third one. Let me maybe just show you before working on this puzzle what kind of the standard way would be to swap the values of two variables if you weren't really thinking too much about it and just wanted to, swap positions. So let's set up some variables. We're going to have int number 1, number 2. Integer number 1 is going to be equal to 3. Integer number 2 is going to be equal to 4. And now our goal here is to get number 1 to be equal to 4, number 2 to be equal to 3. This is, something that comes up pretty often in computer science is you have two places where you have different things stored and you want to swap them around. Well, if you can think of it like that, you have one thing here, and you want to swap them. Well, the issue that comes from just being like, all right, let's do this. Number 2 equals number 1. Number 1 equals number 2. If you think about what actually happens here for a second, you can see this isn't really going to work out too well. Let me output what is going to occur, and we can see why this is not going to be a correct solution. Number 1 is number 1. Number 2 is number 2. Let's see what happens here. So what we want is, originally this was 3, 4. We want it to be 4, 3. And let's see what happens when we run this. That's no bueno. Number 1 is 3. Number 2 is also 3. And the reason for that is because we want to have them go like this. Take one from one, put it in the other, and move the other one over. But what actually happens is, in this line here, number 19, whatever is in the second box replaces what's in the first box. Oh, by the way, this is our class mascot, Cheeto. You gonna say hi to everybody? No, you're just gonna lick my nose. Okay. Anyway, tangents. What ends up happening is what's in the second box replaces what's in the first box. So that 4 gets overwritten by the 3. Or sorry, I have it the other way around. The first box on the right side, so it replaces the second box. And so this 4 gets, essentially eliminated because it's just replaced by the 3, and now all we have is just 3. Every integer is 3. That's not great. So what if, instead of, doing this, because this doesn't really work right away, we have a spot to temporarily store one of them, so we can take, our 3 and our 4, and we can go hold the 3 up here in the temporary spot, slide the 4 over, and then bring the 3 back down. That's what we want to do, right? So we'll use a temporary variable for that. We'll call it temp. And instead of doing this, because this ruins things right away, we're going to say, all right, whatever is in our first spot, we're going to put that in the temporary position. Now, since this is saved, number 1, our 3 is saved, we can go ahead and overwrite what's there with number 2. And now, before I write this line, think about it for a second. What is this last line of code that should be here? And the idea here is that we've now temporarily stored our 3 up above, and we've slid our 4 over into the new spot. So our 4, which was number 2, is now being saved in the number 1 variable, and we need to grab our 3 back. And our 3 is stored in temp. So we need to get our 3, and we're going to put it in the place that we're swapping it into, which is number 2. So now if we do this, it should be correct. Hooray, number 1 is 4, number 2 is 3. Now, this is how you do it with an extra variable, but can we solve this without using a temporary variable? It's a little bit of a puzzle. You can think about it for a bit, but the answer is essentially that, if you remember, I mentioned that by putting the 3 over here, you're overwriting what was there. Well, what if instead of overwriting, we add them together? And think about the order and how this is going to go. So let's get rid of our temporary variable, because we're supposed to do it with just 2 variables. So we're not going to have a temporary one. This apparently had something weird going on. Now, we if we add them together, we're going to get 7, right? So let's say that for the sake of argument, we take number 1 and we store in it the sum of number 1 and number 2. Whoops. Plus number 2. So number 1 now has 7, right? It's 4 plus 3. Number 1 has 7, and number 2 has still has 4 in it, okay? Now, here's the thing. From 7 and 4, can we get 3? Yeah, we can. We just subtract, right? So our goal here is to get this 4 into number 1. So now that we've stored this 7, we can do that directly. We can just say, or hold one sec, let me think about this for a second. Make sure to do this in the right order. If you do this in the wrong order, what ends up happening is everything kind of gets erased, which is no good. So, okay, we have our number 1 with 7, our number 2 with 4, and we want to grab the 3, and that 3 is supposed to go into number 2. So number 2 is supposed to have 3, and what 3 is 7 minus 4. So now number 1 still has 7, and number 2 has 3, which is good. We want that to be the case. And now all we have to do is change this 7 into a 4. And how do we do that? Once again, subtraction. So number 1 is number 1 minus number 2. Now, this looks kind of silly, right? Because when you look at the code itself, if we weren't really doing the math in our heads, number 1 minus number 2, number 1 minus number 2, we just did the same thing twice. But because the values are being switched around in here, yeah, I know. Because the values are being switched around in here, when we actually get to this line, it isn't going to give us a 7, it's not going to give us a 7. We're going to have number 1 now has the result of 7 minus 4, which is, 7 minus 3, which is 4. Num2 has 3, as desired. And we run it. Alright, we did exactly what we were looking for. Okay, Cheetah was getting a little antsy, so I had to put him back on the floor. Hopefully he doesn't cause too much disturbance. Anyway, let's start looking at actual if statements. So this exercise requires us to write a program that reads in a character from the user and prints a message if the character is an uppercase letter. So there's a few parts to this, and whenever you see a program or a problem that you have to solve that has a bunch of components, just worry about doing one at a time, and you can worry later on about how they all fit together. So let's just start out with the simplest first little part. Write a program that reads in a character from the user. We've done this already, so this shouldn't be too hard for us to put together. So we'll get rid of everything from the last exercise. Read in a character from the user. So first thing I need is somewhere to put a character. The user character. Anytime that you're going to get something from the user, you should tell them, please enter a character. And then that's going to go into our variable. Okay, cool. So that's the first part done, right? Not too much to it. Initialize a variable, ask them for a letter, they give you one. Okay. I'm not in the character. Now, I'm supposed to print a message, but I'm only supposed to print the message if the character is an uppercase letter. So, for anything else, I need to figure out how do I know if something is an uppercase letter. And this goes back to the previous lecture where we were talking about the integer representation of characters. So when you look at two different characters from the computer's perspective, it just sees them as numbers. It sees everything as numbers, zeros and ones, right? And so all the characters that you can think of, including letters, all have numerical values. Just as a reminder, if I were to print out the integer value of the letter A, integer value of the letter A is 97. Now, notably, let's try printing out the integer value of a capital A. This shouldn't be 97, right? It's a different character. But what is the value? 65. So, what we're going to need to do is figure out how can the computer tell when the character that we have is a capital letter. Well, it's a capital letter if the integer representation of that character starts from 65 and goes to as late as, well, let's find out, right? Sorry, I should probably correct this. And goes as far as Z. 90. 65, there's 25 more characters, leads you to the 90th. So if the integer representation of my character is between 65 and 90, then it must be uppercase. Now, fortunately, you don't have to actually do the math, because, conveniently for us, the computer can just do this for you by telling you, is something greater or less than something else? So if I were to output instead, is the integer value of Z greater than the integer value of A. Oops, one sec. Yeah, I put all this in parentheses. It gives me 1, which is true. 0 is false. So, and this is because, again, 90 is greater than 65. Now that I know I can do this, well, if the character I've been given has an integer value that is between capital Z and capital A inclusively, then I know for sure that it is a capital letter. So let's try to build this expression, because this is kind of the trickiest part of this problem, is figuring out how do I determine if it's a capital letter, and there's a multi-part expression we're going to use for this. So first off, is my character, does it appear after the capital A? It needs to, otherwise it's not. After or equal. It has to, otherwise it's probably some other kind of symbol, which is not what I'm looking for. So the first part of the expression is the integer value of my character is greater than the integer value of A. And specifically, it's actually greater or equal to the integer value of A. So this is the first part of this. And now, just to sanity check what we have so far, let's actually again output this value. So I'm going to take this, I'm going to put it in here. I think I have an extra parentheses there. Okay, so this is going to tell us if the integer value of our character is greater than the integer value of A. So let's try it out. Okay, enter character. Let's try B. I know for sure that B is going to be greater than the integer value of A. So let's try it out. Hooray, 1. All good. Now let's try something we think might not necessarily be an uppercase letter, say a number. Let's try, 7. If I enter 7, the output here is 0, which means false, because the integer value of 7 is something that is lower than 65. I believe it's like 50 something. So this is the first half of the expression I'm looking for, is something that appears after a capital A, but I also want it to appear before capital Z. So I'm going to need a second part, which is going to look basically the same. It's just like this. But it's going to be before capital Z. Okay, now I have two parts, I have two separate expressions, each of which could evaluate to true or false, and I want to combine them together. And this is where we start getting into our binary operators, for instance, and, or, not, and so on. And in this case, I want a capital letter to be one that appears equal or after a capital A, or before or equal to a capital Z. So, to combine them together, I can say I want this to be true, and I want this to be true. So, by having them both combined together, I get a gigantic Boolean expression. And I can say, if this is true, then I will do something, which is I'm going to output a message, which is going to be, this is a capital letter. And if this is not true, then I will not output this message. So let's try this a bunch of times and make sure it works with a few different examples. So did I code this correctly? I hope so. Let's enter something that's not a capital letter. So 5, not a capital letter. How about a percentage? Nope. How about capital W? This is a capital letter. Look at that. And you can test it some more if you like to. But this line of code looks really convoluted and confusing, and we actually can simplify it conveniently, because it turns out that you don't have to tell the computer to convert stuff to a number. You can just use it. So everywhere that I wrote int here, you actually can just get rid of it. Int, 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 int. Ooh, looks a lot simpler, right? Just does it appear after A and before Z? If so, yeah. And turns out it's the exact same program. Plus is not a capital letter. You know, underscore not a capital letter. Capital Z is a capital letter. Capital T is a capital letter, and so on and so forth. You can feel free to try it out as you like. Okay, on to our next exercise. Write a program that compares two integers and prints out a message to say which is larger. If the first integer is larger, also print out a message if their difference is less than 4. So there's a lot of ifs in here, which, as you might imagine, means that we're going to have to combine a bunch of them in some interesting ways. So let's take a look at how we do that. Now, in my first if statement that I made from the last exercise, there's a few things maybe I glossed over a bit quickly that I want to make sure that we're familiar with. First off, the keyword if is important to indicate, obviously, we're using an if statement. Now, there are two curly brackets here. These are called braces, and you can either format them like this or like this. Doesn't matter too much, but the important thing is that in between these opening and closing braces is any amount of code that you want that will only ever run if this condition is true. And this condition here is a bit of a complicated condition, but it's basically, does something appear alphabetically after capital A and before capital Z, meaning it has to be a capital letter. But these conditions can be anything you want. And so for this one, let's look at the conditions we're going to need. We need to print out a message to say which is larger. Well, what that means is, if you think of it another way, we want to print the first integer if it is print a message to say if the first integer is larger, and if it's not, then print a message to say the second one is larger. And we'll worry about the second half after. But for now, again, anytime you get a problem, just break it down into smaller components, and like good computer programmers, we're going to combine everything accordingly as we go along. So first step, compare two integers, print out a sentence to say which is larger. So let's erase everything we have here. We don't need it. We need two integers. So, whoa, integer number 1, integer number 2. Let's give them some values, shall we? Number 1 can be 10, number 2 can be, let's say 12. These ones are close. Okay. If number 1 is greater than number 2, then I want to print out that that's the case. Number 1 is bigger than number 2. If it's not, I'm going to use else if. This basically means suppose this is false, then consider an alternative, which is that number 2 is bigger than number 1. If that's the case, I want to print out a different message, and I want to say number 2 is bigger than number 1. Now you can probably guess there's one more possibility, and now I could do this in two different ways. I could either do else if number 2 and number 1 are the same, and now here's a very common mistake that people make, and this is something that's going to be very important, which is when you use the equal sign in computing and programming, this doesn't mean equivalency. This means take what's on the right side and assign it to the left side. So when you write num2 equals num1, you're doing the same thing as if you wrote this as a line of code down here, which in an if statement you don't want to do. Anytime that you're usually putting something like that in an if statement, what you actually mean is if these two things are equivalent. And when you want to do that, you actually need two equal signs to indicate they whether or not you want to know if these two are the same thing. Now, it turns out we actually don't need to do this at all, because if number 1 is bigger, then we go this way. If number 2 is bigger, we go this way. And there's only one other possibility, which is that they are the same. There's no alternative choice beyond that. So instead of saying else if all this, you can actually just say else, because any other case that could happen must go in this last possibility of they are the same. Okay, so if I print this one out, Number 2 is bigger than number 1, which makes sense. If I update my number 1 to be 14, it should go the other way. Number 1 is bigger than number 2, and if they're both the same, they're the same. Now, that was only the first part, because I also need to see if the first integer is larger, then also print out a message if their difference is less than 4. So, there's a few things in here. First off, if the first integer is larger, well, I need to go to the part of my code that refers to the fact that the first integer is larger. So that is this part. The first integer is larger is all the code that occurs between these braces here. Now, if their difference is less than 4, well, how do I figure that out? I have to subtract them and see if that is 4 or less. So if and now, how do I know which to subtract from the other? Well, fortunately, I know because since I know I'm in this block of code, I know that number 1 must be bigger than number 2. So I know that the difference is calculated by taking number 1, the bigger number, and subtracting number 2, the smaller number. This gives me a number, some integer. If this difference is less than or equal to 4, then I'll print out my extra message, which is they are not so different. Any message you feel like, you know. And I believe that's actually it. Not too much that we had to add here. But the critical thing is that this is now an if statement inside of an if statement. So the only way that this bit of code in here gets run is if not only is this thing true, but also this thing is true. So let's double check. First off, if I run this normally, nothing really should happen because they're the same. And if number 2 is bigger than number 1, then again, all this code won't actually run. It'll just tell me number 2 is bigger. But if they are close, say I have 17 and 15, then number 1 is bigger than number 2, and they are not so different. And sadly, I forgot to add a little space in here, which I should to make it nice and pretty. Let's do that one more time. Number 1 is bigger than number 2. They are not so different because they're only 2 apart. And that's it for that exercise. Okay, last one. Write a program that reads in a letter grade from the user, then uses a switch statement to make an amusing comment about how well the user is doing in the course. Don't forget to account for invalid letter grades. We're also cheating a little bit here in that, normally when you think of letter grades, you think of things like A+ or B- or something. We're just going to take a letter, and that's it. So we're using a switch statement here because although you could do this with an if statement, it's a little messier than just using a switch, since the switch is all going to be effectively taking a bunch of if statements that would otherwise be if this variable is f, if this variable is c, if this variable is b. You can just instead use a switch and say switch on this variable, and then here are the possibilities: f, b, c, d, a. So let's do that. Okay, first off, we need to read in a letter from the user. So my grade is going to be a letter I get from the user. Please enter a character. Then we're going to get their grade. Okay, we got a grade. Now, we want to run code based on the grade that's there. So we construct a switch, and inside the switch is our grade. And now, inside of our switch, we use cases to determine which piece of code should run based on the value of the grade. So one case could be you got the letter A. One case could be B, C, D, or F. F, D, C, B, F. And then finally, there's one more case, which is kind of like our else from our if-else statement, which is default. And this is if none of these other cases are met, then we go with the default. And our default here is, of course, that this is not a valid grade. Now, for all of our other cases, there's two things that we have to put in here. First is whatever code we want to actually run. So if they have an A, I probably should output this message, right? If they have an A, then I want to output, great job, smarty pants, or some other silly message. And the second thing we have to put in here is a special word called break. And this break is essentially telling C++, okay, this case is the one that we were looking for, don't continue onward looking for other cases. Otherwise, what will happen is it starts going through all these cases even further, but usually you don't want to. Once you've met the condition you were looking for, you usually just want to run the line of code that's in there. So this break and a message is going to appear in each of our cases. Message, message, message. We'll change the messages up a little bit. You know, how very fine, perfectly okay, and at least you passed. And let's try, oh yeah, the last one is failure. We're just going to give them a sad face. Sad. And let's try this out. Hopefully I didn't break anything. I think it's all good. All right, let's enter a character. Say I got an A. Look at that. It gives me my great job, Smarty Pants. And that's what I was looking for. If I enter something that's not a grade, say number 9, it's not a valid grade. And I can enter the other letters just to be sure. Very fine. Perfectly okay. At least you passed. And F. Sad. But hey, don't be sad, because now we have gotten our assignment done. All the exercises that we were going through for control flow. If statements, switches, if else, else if, and so on. So hopefully this video was helpful, and stay tuned for the next one.